My name is Jonas Anund Vogel, and I'm a director of KTH LiveIn Lab. That is a testbed for innovation in the building and the housing sector. So I started as a researcher at KTH like 7 years ago, and then the last 3 years I've been working full time to get this testbed up and running. So with that said, I start. Here we have two pictures, one showing a modern apartment and another a modern car. The question is, why do they differ? They're produced in the same world, but when you want to get fresh air into the apartment, you walk and manually open up the window. What do you do in the car? It's designed to give you the services you want at the time you need them. You have climate control, auto brakes, speed control, and soon autopilot. Why are buildings designed to make it possible to stay indoors instead of joyful? Buildings account for almost 35% of the energy used in the world, and 40% of the CO2 emissions are connected to buildings. And now we need to produce 700,000 new apartments in Sweden over a period of 10 years. So how should we produce these apartments? Should we produce them like the Swedish building code says, 90 kilowatt hour per square meter and year? If we do that, we need to produce a nuclear reactor or 1,000 2 megawatt windmills. If you as a developer just go to a quite decent shop and buy good windows and some insulation and a heat recovery system, we could lower the energy usage to half, 45 kilowatt hours per square meter and year. And if we just start to think a bit and connect the different parts, solar PVs with heat pumps and wastewater heat recovery systems, we can get plus energy buildings easily. But why should we do that? Why should developers do that when they don't need? Well, partly it's good for the environment. We save energy, decrease CO2 emissions, and you get better return on investment as well. And if you don't believe me, well, quite many might not believe me, so that's what we're gonna show you. So we're building a testbed. It's partly a demonstration project and also a testbed for new innovative technologies. The demonstration project is 305 apartments where we collaborate with Einar Mattsson. So the roof is fully covered with solar PVs, 1,150 square meters. The solar PVs are connected with heat pumps and 3,600 meter boreholes. Together they generate the total use, the 230 kilowatt hour that is needed for this building per year. But apparently students, they shower twice a day. Not my figures, Einar Mattsson's figures. So we need to recycle the heat from the wastewater. So the buildings are equipped with 50 wastewater heat recovery systems. So we could recover almost 50% of the heating in the water. We're also a testbed, and innovation in the building sector occurs as stepwise reconfiguration. We live almost the same now as we did for 2,000 years ago, but we have better windows, more insulation, new technical systems as heat recovery systems, heat exchangers. And when you combine these stepwise reconfigured products, you could reach something new, radical innovation. As here, an apartment without water-based radiator systems. So this process took 80 years, but we don't have that time now. We need to get the new technology into buildings instantly. So that's why we have created KTH LiveIn Lab. It's a testbed that is building permit free. So here we can test technologies that we cannot test in an ordinary building sector. So we test different technologies, we combine them into system, and if they work, if they are proven to be better than the ordinary old technologies, we introduce them to the market buildings are changed, and after a while we have transformed the whole building sector into something new, something more sustainable. This also have an impact on the landscape level, on the regulations, norms, how we use buildings, how we produce buildings. So that's how we reach transformation of the whole building sector. So how do you actually design a test bed that should make it possible to do research on everything, from wastewater heat recovery systems to behavior or allergens in the air? Well, of course, we're working at KTH. We asked the students. So we gave this task to the students at architect school. And one student thought that, well, maybe it's good to produce some personal pods that you could bring with you when you move. You take your pod, put it in a common space where you have toilets and you have kitchens and everything, and then you have your own private pod. When you move, you just take out your pod and move it to the next common space. Well, it was a nice idea, but didn't work perfectly with all the research projects that we were thinking about. So another student thought about how small can apartments be compared to a big common area. So the apartments were 5 square meters and the common area were around 100. But that didn't fit so well with our research projects either. But another student were thinking about 4 ordinary apartments with sliding walls. So here we could do tests on apartments that are similar in size that the 305 apartments in our big demonstration project. So we could see statistical changes in our test apartment compared to the ordinary apartments. But we can also slide away the walls and see how often do people use their own kitchen compared to others if it's open. We could see how often there are in the private places compared to the public. And we have shown this to developers that makes hotels and elderly care. And to make dead hallways alive during daytime, to have a possibility to have conference spaces close to the rooms in a hotel, that opens up a whole new business model for hotel owners. So this is what we're going to go forward with, 4 apartments with sliding walls. But we don't stop there. The next year, we just reproduce everything. We might try 6 or 8 apartments. The test bed is totally flexible, both interior with walls, bathrooms and everything, and also with the installations. So depending on the research and test projects that we would like to test, then we rebuild the apartments so they will fit the purpose. Below the apartments we have the basement where we have all the installations that makes the research possible. So we have heat recovery systems and electricity storage, hot heating storage, both in phase change materials and water, and wastewater heat recovery systems and everything. So down here, students can work with research projects, and the researchers could be there. So we get a real live-in lab when the researchers, the academia, the students, and the companies get together. As I said, the installation system is totally flexible for doing all kind of research. So far, we haven't found a research project that we cannot do yet. So the red thing here, the red lines are the ventilation shafts. So it's prepared for 8 apartments, but we have only connected 4. But we can also have the ventilation from underneath or above, depending on what research we would like to do, to try different ventilation strategies. And you can see that the apartments are built within a 5-meter high office, and they are 2.4 meter high, so we can get in with sensors from underneath and above. We're also producing a virtual reality model so that we will start the research in the model, test new strategies, new control strategies, adaptive control systems or whatever, and then test it in the virtual lab. If it works, we then test it in the test apartment, and if it proves to be successful even there, we test it in the 305 normal apartments. And if it proves to be successful there, then we have huge possibilities to actually change the market. We have put in too many sensors, I would say. We have sensors for everything all over in this lab. So everything from CO2 and temperature to tap water, noise, pressure, and also allergens. I will come to that later on. But one interesting project is how many sensors do you actually need? Old buildings might not be feasible to put in new technical systems and hundreds of sensors. But if we here can develop adaptive control strategies based on hundreds of sensors, but that could work out well for old buildings with maybe 2 sensors, then we have reached a real milestone. We're also designing a huge database for building and user behavior data. So we take in data from our test bed, we take data from our 305 apartments, and through a collaboration with Akademiska Hus that owns all the campus buildings here at Valhallavägen and almost every building in Sweden connected to campus, we get huge amount of data. But we will start with this education building that is newly produced as well. But we don't stop there. We will deliver Arduino kits to the students. It's like small home computers, small microcomputers with sensors. So we will give away this package and make it possible for students to connect to LiveIn Lab, to deliver their data to us. So we will hopefully spread like a virus throughout Sweden, maybe the whole world. So these are some examples of test and research projects that we will start. We have the adaptive control strategies, so where we will make it possible for the system to adapt to person's behavior. If someone opens a window, then maybe we lower the temperature. So the next day when the person comes in, if the person still opens the window, even though it's colder, then we might increase the ventilation and see if it's that problem. If the person still opens the window, then it might be something else, and then we just put it standard, because then we can't really control that with our system right now. We also have a project with behavior. So how would you actually change a student's behavior within a building? So there are 2 kinds of nudges and boost, 2 kinds of interventions that we will test here. So first we look at how people behave in the apartment for 3 months, and then after 3 months we add 1 kind of intervention to 40 students, a nudge, someone picking on your shoulder, like a shower head that turns red after 5 minutes, indicating that now it's time for you to stop showering. And then another group of 40 students, they get a boost instead. And it's more of a education. So people get to know that, okay, if you take a shower longer than 5 minutes, this has this kind of impact on building level, this kind of a national level, this way on the international level. And then we will see if the behavior change. And then when the intervention is over, the student get back to live without intervention for 3 months. And then we look, did this actually has long-term impact or not? And that's what we want to find out, if we can have a long-term impact on the user behavior. Another quite interesting project that we will start is allergens and pets. So around 15% of the Swedish population is allergic to pets. And quite many still live with their pets even though they are allergic. So Karolinska Institute here, they contacted us and asked if we could develop a kind of laundry machine for pets. We were, well, go on. It should be in the entrance, and it's like you take your cat and then out comes a clean pet. And then we don't have any allergens in the apartments. But we were thinking maybe a cat could go in there once and probably not twice. You can fool a dog in there maybe 5 times and then it's over. So we thought maybe it's better to develop a ventilation system that could detect the allergens and then adapt to force to suck out all the allergens from the indoor air. They liked the idea, sounded a bit better. So together with Karolinska, we're developing different ventilation strategies to actually detect allergens in the air and how to manage this, if we could suck them out through the floor or above to actually make all apartments usable for all users. There was just a few projects. We have 28 projects that will start sooner or later. And if you would like to test things here, just go into our homepage and click to test products or do research. So this is our yearly cycle. During the summer we will reconfigure the apartments according to the research projects and test projects that has been sent in to us. Then we start courses that will have an impact on the next year's design of the apartments. And during the spring we have evaluation courses evaluating how the apartments actually work. So here it's a big opportunity for students, academia and industry to actually work together in order to make future sustainable buildings possible. We also have 2 yearly conferences where we present our results. And all the way along we have researchers just doing research here together with the companies. Yes, that was it for me for this time. So I hope that you would like to use our testbed. It's open for everyone. Just go into our homepage, as I said, and apply for using it. We cannot do this change by ourselves. We need you. We need the companies, academia to actually engage. So thanks.